Good afternoon, everyone. One of the things that we will be talking about today is ratios. So this is one of the first topics that we'll be dealing with this unit. And so some of the things that we'll be learning today is how to identify types of ratios, how to reduce ratios to lowest terms, how to understand relationships of ratios, and how to solve problems involving equivalent ratios. So to begin, I'd just like to introduce the idea of what a ratio is. Okay, so a ratio is a comparison of quantities, right, measured in the same unit. Okay, so what it looks like is a number separated by this colon right here, and followed by another number. How we would read this in words, we would say 3 for every 4, or sometimes you would hear it 3 to 4. Okay, 3 parts, right? 3 parts to 4 parts. Okay, so a fruit punch, okay, is a great example of something that we all know and very familiar with. And so sometimes when we make fruit punch, we say that we make it with pineapple juice and lemonade. And so we can say that the ratio of pineapple juice to lemonade determines how sweet or tart the flavor will be. Okay, pineapple juice tastes sweet. We all know what pineapple juice tastes like, and lemonade tastes tart. Okay, another word for tart is sour. Okay, and we all know that when we bite into a lemon and our face makes that funny face, well, that's what sour tastes like. Okay, so if I was going to make lemonade, I would need part pineapple and part lemonade. And to think about, how these parts would affect a recipe. Well, if I wanted my pineapple, or I wanted my fruit punch to taste more sweet, I would probably add more pineapple. So if I had 2 parts pineapple to 1 part lemonade, you would see here that I have more, right? I have more sweet than I do sour. So my fruit punch would be more sweet. Perhaps I wasn't really a big fan of something sweet, and I wanted something to taste a little more sour, a little more refreshing for a hot summer day. I might want to make it a little more sour. Okay, and so if I added more lemons, then you could see very visually that I would have more sours than sweet, and so that my fruit juice, my fruit punch, would taste more sour than sweet. So there's a great way to think about ratios. Recipes is probably the most common example that we see every day, and I'll come back with a couple more examples. The first ratios that I can create is a part-to-part ratio. So knowing that I have 7 red beads and I have 6 blue beads, if I wanted to create a part-to-part ratio, so I can compare the red beads to the blue beads, so a ratio of red to blue, okay, simply replace the red with the number of red is 7, and we have 6 blue beads, so we have a ratio of 7 red beads for every 6 blue beads. On the other hand, I can actually write this in a different order. So it's nice that if I'm talking about the ratio of blue beads, right, blue beads to red beads, okay, then I can simply just reverse the order, because I have 6 blue beads, okay, for every 7 red beads. And so okay, we just saw an example of a part-to-part ratio, and so another example of a ratio that we can learn about is a part-to-whole ratio. So remember, we had 7 red beads and we had 6 blue beads for a total, okay, of 13 beads altogether. So if I wanted to create a part-to-whole ratio, I could compare one part of the group to the whole group. Okay, so one example of a part-to-whole ratio here. So our whole group here would be 13 beads, right? I have 13 beads, and one of the parts I have 7 red beads, and one of the parts I have 6 blue beads. So one example of a part-to-whole ratio would be the number of red beads, okay, the number of red beads to the total, right, to the total number of beads, to the total beads. So you see here that I have 7, right? I have 7 red beads, and I have a total of 13 beads altogether. So the ratio of red beads to total beads is 7 to 13, and I can also say that I have 7 red beads for every 13 beads that I have. Now every part to whole ratio, right, can be written in the form of a fraction. Okay, so 7 red beads for every 13 beads I have. I can also write this as a fraction, right, is equal to 7 over 13. Okay, so a nice little tie-in with some of the things that we've learned in grade 7 and 8, and taking it to a new level in grade 9. Two ratios are the same, right? The same or equivalent when written in lowest terms. Okay, so a ratio, we can write a ratio in lowest terms if I can find a number that divides evenly into both parts. So this is where this stacking method becomes really important that I talked about. Things up nice, right? I keep my ratio sign lined up with my other ratio sign, and I'm looking for a number that divides evenly into both parts. I know that that 4 and 10 are both even, so I can go ahead and I can try 2. Okay, so whatever I do to one side, I can do to the other, or I have to do to the other. So 4 divided by 2 is 2, and 10 divided by 2 is 5. You know, both of these numbers are prime, and so I know that I can stop there, that these are in lowest terms. Once again, I'm going to keep things nice and stacked, right, lining up my ratio symbols, and I'm looking for a number that divides evenly into both 6 and 15, into an odd number. So I'm gonna try 3. Okay, so let's try 3. 6 divided by 3 is 2, and 15 divided by 3, right? 15 divided by 3 is 5. So we can say that these two ratios are the same, right? Or we can say that they are equivalent, right? They are equivalent because they can be expressed as the same ratio, right? The same ratio when written in lowest terms. Just before we finish up, I'd like to revisit our learning goals. So today we identified types of ratios. We talked about part-to-part ratios, part-to-whole ratios, and equivalent ratios. We understand that a ratio was a comparison of two quantities of the same term. We learned to reduce ratios to lowest terms, right, when we can find a common factor that divides evenly into both terms in the ratio. We learned to understand the relationship of equivalent ratios. Okay, so how ratios can compare to each other. And also we started solving problems involving equivalent ratios, but this is one topic that I'd like to revisit with a few more complicated examples. So until next time, keep solving problems, keep watching videos, and things will definitely improve.